In the last class, we have discussed about how the transfer learning can be used to apply, like take a pre-trained model and use it for some other task, right? So similarly, we are going to do the same here. Like we'll implement, take some pre-trained model and then use a different kind of a data set and then use it. Okay. So this code is also available in TensorFlow tutorials. So when you go for like transfer learning and fine tuning, you will find this part of code here. So let's we'll go step by step, explain each part of code. Okay. So let's go further. So, and like for this tutorial again, just like previous sessions, like I'll be using Google Colab for running this code. Okay. So let me use the same. So I have copied it and then I've created a new notebook here in Google Colab and I'm running it. So these are few libraries which may be required for plotting and all. So and actually there is some if it is for images, actually TensorFlow contains some functionalities where you can do pre-processing for images. Okay, till last sessions, for images we only did one kind of normalization, right? So which was like divided by 255. But here this library will make use of it and then do few other modifications. Like we'll see like what all those are. So okay, so this is about the functions, and in this example they have taken data sets for cats and dogs, so which is actually like a set of images, like few cats and few dogs, and our model needs to differentiate between, like classify between the images which are containing cats and the images containing dogs. Okay, so let's do that. Here is the URL for the dataset. If you use this, then it will automatically download the dataset. Okay, let me use the same, and then once that is done, and actually it has like two direction, train and validation. So it will automatically be saved in that way. So let me open that. So okay. So let me take this. So let's see only till here. Let's do it by part by part. Okay. So let me copy it here. So this is URL and here is a path to zip. Actually, it's a zip file, right? So this your keras-utils.get file, actually here it is a zip file. So one more thing, it will download the file. Okay. So this is, and then what we do is, like, here is also a path to it. So for that path, we also have to extract, right? So that extract is here. So extract to true if you give, it will also extract and save that here. Okay, let's see like what it will do. Let me run it. So you can see it is downloading this file from here, and then it will start extracting as well. So let's see what is there in this. So let me give path. Okay, os dot list dir of this path. Let me see what is there inside that. See, actually in this path where it has extracted already. Okay, so after extracting, this contains like two folders, which were like validation and train folder, and there is also a file vectorize.py. Okay, so but we are actually, this train and validation are data set has been already split into train and validation, so we'll use the same. Okay, so the train directory is in after the path there is one more folder like train, right? Similarly validation, there is after the path, which was this. So path is this thing, and in that there is a folder validation. So let's take those as a separate directories here. So train there and test validation there. Okay, so after taking it, so then actually here what they are doing is they are actually this image data set from directory. In case if you give like directory which contains images, and this will automatically take the batch. Like if you define a batch size, it will automatically send like images in that batch size. Okay, it's kind of a pipeline for your like model. Like before you send to your model, okay, so the data, it actually implemented a data pipeline inside it. So you can also mention if you want some kind of modification to it, like it will automatically do. So let's see those, like that also will be, that kind of code will also be there. So let me do this. So what it is do is, like first we are also mentioning the size of image, okay, as 160 by 160. So it means like if in case if it is a different size, it will resize it to 160 by 160. Okay, but because we don't know if the size is same, right? So, but for the model, as of now, we will be sending the same input size always, right? All images, we assume that like they are of same size. So for that reason, it will get resized to this 160 by 160 here. Okay, and like anyway, if we keep shuffle as true, it doesn't take like first 32 as one batch and second 32 as one batch. It will do a shuffling, random shuffling, and then take it. So let me run it. Okay, found there are like 2000 images it seems, and between two classes. Okay, so training contains like 2000 images. Okay, so let's also see like what is there in validation set. Okay, so this contains like 1000 files here between two classes belonging to two classes, right? So there are like cats and dogs, two classes here for this data set. So these contains those. And then actually in case we want, you can plot, this is like a code to plot it. So few like images here, they are taking top, first 10 images. Actually range of 9 is from 0 to 8, so 9 images, they are plotting it like this. Okay, so we can also do from this, like we can check actually if that like what images, what is the data set, what it contains and all. Okay, let's use the same code. So here what they are doing is data set, this train data set dot take one, in the sense like it will be like one image at a time. So okay, so that will be stored in image and the label will be stored in label, and then here we are plotting it. Okay, so let me run it. Okay, so while running it, okay, see here there are like, there is a dog and it is labeled as dog. It is a cat which is labeled as cat, right? So similarly for all others as well. So now our model, if we feed this as a what is it, like we feed this as an input, each of these as an input, then it should be able to classify that it is a dog or it is a cat. Okay, so let's do that. Okay, so what you can also do is, there is some part of code like as a original data set, original runner, you will create a one. So apart from this test, right, like we currently have only two batches, right? What is train and test? Like here they called it as validation, but we can keep like three actually one kind of a holdout set, like just like how when I have explained about like how to split the data set, we used to have like three different, right? So train, validation, test, or maybe train, validation, holdout. You can call anything different. So same way, like as of now, we only have like train and validation over there. So here, what we can do is, like by doing this way, some part of batch will be a part of test. Okay, so what it is being doing is like validation test, like out of which you are taking like divided by 5, so that take will be like, actually it will give output. Okay, and then dot skip actually will skip those things in the data set. These are like implemented functionalities within, but anyway, if you can assume that it's a kind of an array out of which you randomly pick 20% data of that and make it as a test set and remaining as a train set, or maybe you can use just scikit-learn's train test split, right? So that API can also be used, like that anyway will be more familiar compared to this, right? So, but as of now here, to maintain the continuity, let me use the same, but you can use that as well. Okay, so let me run this. Okay, so it has run. Let's see what actually this contains. Okay, so let me see dot dir. Maybe shape, all those things will be there. Okay, these contains like something similar. Okay, filter, skip, like this is there. Is it shape? Those are not there. We have to use like take or skip again for getting the values from here. So okay, let me delete this. Okay. So now next what? In case we want to look at like how many batches it contains. Every batch we know like it contains like 32 size, right? So how many batches does it have? Indirectly gives you like how much is your shape of your what is the shape of your test set and validation set, right? So here there are like 26 batches. Here there are 6 batches. Okay. So this is how it is now. So now let's go forward. And there is like something like this is not required as of now. This is for like auto tuning, like the parameter tuning, it will do automatically. So buffer prefers to load the network without. Okay, let's use it, like we'll talk about it later at a different point. Okay, so as of now let's use this part of code here. Okay, cool. So next thing, like now the actual thing comes up. So now you have the data set ready with you, and now you have to, what you have to do, like you have to use it for training. Okay. So but there can be few regularization techniques which we can use, right? Just that usually deep learning models are prone to overfitting, and then in the last session, like we have discussed like what kind of techniques we can use to reduce the overfitting. So one of them is like L1, L2 regularization, such kind of things you can use. And one thing is dropout layer you can use. And one more thing is like data augmentation, what you can use, and so on, right? So let's use this dropout and L1 now, like those we can see while building the model. So before that, let's handle with the data. So because you can see the data is very less, right? So just 2000 examples for training and 1000 examples for testing. So what we can do is we can increase the size of data set by doing a kind of minor changes to the data. Okay, so here instead of we doing it like separately, like write a code for it. So like all those kind of modifications, those are available within TensorFlow itself. So here in this code they have used a random rotation of 0.2. It will actually convert into degrees at later, and then it will do that rotation. And then similarly random flip, they have used random flip as well. So similar, these two are the augmentation which were used. If you use this on top of it, it's a kind of a layer. Okay, so if you use it with your model, it will automatically do this, and then it will for training it will use it. Okay, so we'll see that later. But as of now, if you pass your model to this layer, what it will do is it will do a random flip horizontally. So what indirectly it's like a kind of inverting the image, like horizontally. Okay, so similarly a random rotation point two will be like doing a kind of a rotation here. So these are like actually this will help for a model to generalize quite well, because like you give some disturbance to the data, and still like we are training such kind of data set, right? Usually if you want to collect the data, maybe in case if you are very particular, the data set might be very clean and doesn't have these rotations and all. Maybe the cat always is straight. So in case in test set or in real time, you find that cat like which is jumping on air, which was in air and which was to a certain angle, then maybe the model did not see such kind of image before, right? So maybe if it did not detect. Okay, so these kind of data augmentation techniques will help the like model to generalize well. Okay, so for that reason, so as of now these two are used. You can add, like feel free to add more to this. Okay, so okay, so I have uses that just define, it is just defining the layer. We did not pass any data set to it. Okay, we'll see like when we'll pass it. So, and then just that if you want to see like what this will do, so let's see this part of code. Actually what it does is, so it is taking one image, and on top of this image they were doing this augmentations on it. Okay, so let's see what augmentation has been done to it. So here they are taking only one image. Okay, so that image, what they are doing is they are passing to this first image. This is the first image. So this image they are passing through this data augmentation. So this is the final augmented image, and let's run and see what it comes. Okay, it's taking little time. Okay, so actually this is your actual image maybe. So, and this image, or is it this, or let's go further. Okay, it's not here. Okay, so maybe this is your one image, and for that what they are trying to do is they are doing a random flip of, okay, it's just like how much flip it is, like horizontally they are doing some kind of a flip here and flip here. So these look, actually these are all same image, but we actually got something like different, right? So it's not exactly same as like how it is previously. It's slightly rotated, or it's slightly flipped from this side, it was now the other side, like that. Okay, so we actually got 9 now data points for the single image. So it has increased by 8, right? So these kind of techniques will help you in doing this, like increasing the data set size and doing this augmentation. Okay, so which will help you, finally help you for reducing overfitting. So okay, let's go forward. So similarly, okay, now this is done. So what we can do now is like we can do this rescaling. Let me do this rescaling and then go for that. So similarly, just like rescaling, what we used to do is like divide by 255. But here, what they did is they divided it by 127.5, which was like half of this 255. So I'm not sure why exactly they use 127. You can still use like 255. There is no problem with that. So like previously, when you rescale, uh, actually like if you want to rescale for like 255, like divide by 255, your values will be between 0 to 1. But if you want it to be in between like -1 to 1, then you can do it by like 127.5, where your values which are less than 127.5 will go for like negative values, and the other way it will be positive values. Okay, it's just like a normalization to get your image data in like 0 to 1, between to 0 to 1, or like -1 to 1. Okay, so and they did an offset so that you will get that between -1 to 1. Okay, so okay, cool. So now next thing like what we'll do is, so should I explain why exactly it will be like between -1 to 1? Because let me show it through calculator. Sorry. So let's say your value is 255. Okay, so 255, now what you're doing is you're dividing by 127.5. So what you'll get is 2, right? And you are to it, you are adding an offset of -1. So your value is 1 here. Okay, so this is a upper boundary, and for lower boundary, what you have is like you have 0 is the lowest number, right? So in the image, like you have pixels from 0 to 255. So let's say 0. For that you are dividing by 127.5, which will be 0 again. To that we are adding an offset of -1, which will be -1, right? So lowest value will be -1 and highest value will be 1, and for a values in between it will be like so some value, let me take 100 divided by 100 divided by 127.5. Okay, so to this value you are doing -1 as an offset, so it will be -0.21 something. So that is how actually your values will get rescaled between like -1 to 1 by using this rescale. Okay, so we are defining all this, like we'll be using it later. So while using, I'll be talking about it. So now, okay, now the actual part has come, like where we are using defining a network and all. So here what we do is, there are in this example they have used a mobile net version 2 like pre-trained model, like which was trained on like ImageNet database, which ImageNet we know like it's a huge database, and like there are like 1,000 classes to it. Even AlexNet and other net also uses the same data set, right? Which we have discussed in last sessions. So similarly now this mobile net is comparatively a smaller model, like which we can they actually intend to use it even to run it in mobile devices as well. So maybe that's the reason the name is mobile net. So to this, like let's use this pre-trained model and try to so this one is actually trained on 1,000 classes, and this may or may not contain like cats and dogs in it. We are not at all like concerned about that. But what we do is, we will remove that last layer, as we have discussed like how the transfer learning works. We will be removing the last layer and add a new layer with just to classify between cats and dogs. Okay, so let's do that, like how it will happen. Okay, so what we should do is, like this mobile net version 2 model, we should be importing it. Okay, so actually when this is available here, so where you can do is like keras.applications mobilenet version 2. This is available. A pre-process input is it's a layer within mobilenet version 2. So let's see like what it contains. Okay, like as of now, let's copy it. When we are seeing a model summary, you will understand what exactly it is. Okay, so let me paste it there, and then I am moving further. So this actually that is a layer. Okay, so we are not concerned about it as of now. So keep that as a layer over there. So to it, what we are doing is, now we are going to load the model here. So the model is available this way: keras.applications.model mobile net, and input shape you can define it before, like what will be the input shape. And to it, these are just weights. Like actually mobile net is trained on like many different like variants were available. You can also download mobile net version 2 pre-trained model. Let me search it. So actually, okay, so let's see here. This mobile net actually contains so many. It has been trained on like like many data sets, right? So you can train your on your data set and then maybe publish that model. So even that you can use it. So this is, I think, home page for it. So data sets overview. Is it something different? Okay, it may be something different. Okay, this is not that site. But actually you'll be able to use. So there is a paper for it, like what exactly mobile net is used and like what it is, and that you can read it later. So here actually what we do is, like it the model is available on, like which was trained on various data sets, and you want to take a model which is trained on ImageNet dataset here. So you can do it this way. In weights, you can specify ImageNet and you'll be able to get it. So let me copy that. Okay, cool. So once this is done, next thing like what we'll do is, so did I do it? Did I run it? Yes. So what happens is, it started downloading the mobile net weights. Actually, this larger URL, right, .h5 is where like the mobile net has been saved, and that it has loaded as a base model now. So you can, what you can do is, you can do this base model dot summary to know what it is inside. So let me look at it. So you can see this is your oh, so starting from here, where your input layer is 160 by 160 cross 3. So and this you have it like these are the layers which you have inside, because we know that like we are dealing with like very large layers, right? So many layers. So these are those things, like you can see the batch normalization, convolution 2D, and even like relu, you could see like few add layers, so on. Okay, it is very big layer, still it's not ended yet. Okay, so we have something like this, a very large model which we are able to load now. But to train this model from scratch, you really need a very good resources, right? So but without that, like because now we are not going to load it from beginning, so we'll be just reusing that. So and then let me do this thing. So here it is just like this is actually not needed at this moment. So okay, so what they are trying to do is like there is a way like this feature batch. Let me skip this and then go to the actual part. This is not required, just to show it. So here what we are doing is, first and foremost thing, for using transfer learning model, initially let's try with like freezing all the layers like of the pre-trained model. And anyway we'll be removing the output layer and we'll be using our own output layer, right? So if you put this dot trainable equal to false, it will actually freeze the weights for all those. Okay, so this way actually it will be easy for it to run. Actually, like this makes all your weights non-trainable, and to the top of this we'll be adding our new layer which will be retraining it. Okay, so let me go forward. This we already did, right? Summary, we have seen it. So to this what we'll do is, okay, let me skip here. These are just to show like what it contains. So actual thing is here. Oh, I may need it. So okay. So what we are trying is, we need a layer, right? So finally, it's just a classification between cats and dogs. There are only two classes here, right? So can it be like dog or not a dog, cat or not a cat? Only one would be sufficient, right? So a dense layer of one, if we keep, would it not be sufficient? It will be sufficient, right? So that's why actually we'll convert into a binary classification now, right? So dog or not a dog. If it is not a dog, let's treat it as a cat, because like this contains only cats and dog. There are no other portion where it is other, so that class is not available. It is just like between cats and dogs. Okay, so we'll, that's the reason we can have a dense layer as one single one instead of having a two. Okay, so your output size is only one. Okay, so now let me jump further. So there is also one more thing which they have used, which was this thing. So along with this, they are adding two layers. Like initially they wanted to be like do a global average pooling, and on top of that they want to use the output layer. Okay, so these two layers are getting added now. As of now it's not added yet, just that we have defined these layers. Instead of writing the whole, we wrote it like global average layer. Instead of writing this whole, we wrote it as a prediction layer. Now we will add it. Okay, so how to add it? First we have to define a model, right? So model equal to tf dot keras dot sequential. So let me copy from there. So let's start this. So okay, so it has been done in the after the in the end. So there are like many ways you can define your model. Like one is this way. Like if you go to our previous tutorials, what we used to do is keras dot sequential, and then we used to define like the layers, model dot add, and use the layers, right? So similarly this is one more method. So let's also try this method, right? Like always instead of doing one. So let me start line by line. So here they are actually this is an input layer, right? So they are defining an input layer here. To the input layer, what they are doing is they're making X. So what this will do is they will do this augmentation. So we have defined this data augmentation one before, right? So it will do that. And to this, it's an X, right? So X again, this is like output of this data augmentation. We are again moving it to something else. So next layer is pre-processing input. So where you do the pre-processing part. So this pre-processing actually you have a preprocessor layer which you have taken for mobile net. So they have provided a pre-processing functionality where you pre-process your image. So that we are directly taking here. Okay, so that layer, and then what we do is we take the base model. So this is what we have already loaded, right? So oh, so here we take this layer. So what this will do is, this is a base model which was like mobile net to which we have loaded here. See, this is the model. So, and this model we are loading it, and you see like this X, we are again passing it to this, and the output again X, we are passing it to this. It means we are actually linking each of these, right? One block after the other. Okay, so this is, or we can also do model.add and then add this, like that is also a possibility. So, and this is like one more way to do it. Okay, and to this we are adding a global average layer which we have it, right? So use that, and then later finally the output prediction layer. And before that, as we discussed before, there are like few regularization techniques, right? One we have already used like data augmentation. Similarly, we can use dropouts. So if you want to know more about dropouts, please refer to our previous session videos. Like you'll be able to know where we have discussed like what dropout is, what drop connection is, and how it will help you in like reducing overfitting and all. Okay, so here for this purpose, for regularization, we are using a dropout of 0.2. So it means this is a key probability. So you can see here this layers dot dropout at rate. So at what rate you want to drop it. So this is what you will see here. So how much of your like you can see here in the description as well. So how much of your layers you want to drop. Okay, so they also have given an example, you can look at it. So use a dropout layer of 0.2 here. So you can usually use like 0.5 is also fine, 0.2 is also fine. Okay, and to this finally we are giving an output layer. What we can do is uh, like actually like after defining output and input, so what we can do is we can form it as a kind of a model to which your input layer, this is input, and finally this is output, and between them is a kind of a model. You can define it this way as well. So previously what we have done in like previous implementation is like we have taken like more tf.keras.sequential, and to it we started adding one each of the layer like consecutively, just like how we used we added this way. Okay, and we don't in that purpose, like we don't have to define again like this is an input, that is an output. It is known automatically. But here, because we are just defining all these like individually and connecting each, right? So and finally here we are defining a model, Keras model, and inputs and outputs. Okay, let me run it. So here you can see till here it's a pre-processing, right? So and this is a model which is a pre-trained, and to it for freezing all the layers to making sure again like training equal to false. And then later what we are doing is we are adding a global average layer, global like average pooling. So and then later we are adding a dropout, and finally a prediction layer. So after base model, right? So what you want to use is your choice again. Okay, so what you think like it will help, you can use that. So instead, like in case if you don't want to use all this, like you can just use this, maybe remove these two lines and then remove these two lines, and after a base model you can directly give this prediction layer. Prediction is this kira dot layer dot dense, but just for a kind of a better performance, like because global averaging is a kind, also a kind of regularization technique, right? So we are using that as well, and dropout as well, and finally going for output. Okay, so this is how it is there till now. So on this, let's see now how one thing remaining is we have to define a loss function and optimizer, and finally run the model. So this is done here. So here you can see, so we can also define a learning rate, or else they will take the default of 0.01 will be taken. But here Remember, for images of larger size, while you're going for a larger model, so have a lesser learning rate. So maybe 10, in 10 power minus 4 or 10 power minus 5. 10 power minus 5 in case like if it is very large. So basically like this will be very critical. If you go only for like 0.1 or 0.01, you don't find it converging at all. So that is one more thing. Usually it will take a default learning rate. So but we can give like one of 0.01, I guess. So but we can also specify a learning rate here. Okay, so optimizer, previously what we used to do is just use Adam as a string, right? We used to pass it as a string and automatically it used to take. So but here, in case if you want to give learning rate or do some kind of modification, so this is a way where we can do. So keras.optimizer dot Adam, and to it we'll pass the learning rate. LR is a learning rate. So and again the loss function, because this is a binary loss function, right? We need a binary loss function, right? Because this is a single 0 to 1 classification model. So we use a binary cross entropy instead of other like sparse cross entropy what we used like in previous session. So and the logic is equal to true and matrix accuracy. This is same. So let me run it. Okay, so now model is configured to train. So let's start training now. Okay. So before that, we can also do a summary and then see what your model contains. So let's also do that. We did not do it after adding. Let me look at it. So this is an input layer and then a sequential and division, subtract. These are all like pre-processing layers. So okay, so just a pre-processing, and to it we are adding a mobile net, which finally actually has these many parameters. How many are they? 22 lakh parameters, right? So that is huge. So in case we want to train it, that's like very huge one, right? So and to it fine we added a average pooling and then a dropout and finally a dense layer where it will connect every other layer to this one, right? One single unit here. So there will be one 1280 and plus one bias term which will be 1281. So finally you have total of like 22 lakh parameters, out of which, because we made it all these as freeze till here, so all these parameters are non-trainable, and you have only 1281 as a trainable parameter. So if you look at the trainable parameters, it is lower, less, right? So it I think like it wouldn't take much time training this model. Okay, let's see that. So that is what is the advantage of using a transfer learning, right? It shouldn't take much time. So let's see, go forward. Okay. So let's do this. History equal to model dot fit trained data set, and similarly you give validation data for here and initial epochs. Initially it means just that it will indicate like from what epoch it is starting. So let me start this. So this we are starting it from epoch number 1, right? So is it 1 or 0? What does it, what should we give here? So let me look at it previously. So initial epoch, oh, okay. So number of epochs, right? So number of epochs, let's say we wanted 10 epochs. So let me do it here itself. So 10 epochs, and this 10 epochs, I'm going to run it. Let me, so fit train dataset and validation dataset here. So finally we can test it on the test dataset later. So you can see there are like 63 batches of train which was going on. So let it run, it will take time. By the time, let me walk you through the rest of the code which was in the tutorial. So what happens is, so you have this run which will actually here, because they might have run it in prod, each epoch is running taking 22 to 19, so an average of like 20 seconds, let us say approximately. So and then finally what we can do is like just like every time what we do, we plot the curves for training and testing accuracies. So this is how it is. So you have validation accuracy and train accuracy curves here. So these looks pretty decent, right? So even loss function if you take, right? So your training and testing loss actually were low. Okay, so this is one thing which you can observe, and this means it is doing pretty well. So this may be because we are already using a regularization techniques. So if you want to do an experiment, remove that dropout layer, remove the data augmentation, and then first try the code, and then see what actually output is, and then again start adding the data augmentation, and then dropout layer, global averaging. All this, we are actually using three different regularization techniques here, right? So remove those and then check like what how is your performance, and then add those and then see what is your performance. Then you will know the difference. Okay, so let's go forward. So this is about it, right? So till here actually we are now able to use a transfer learning, like use a pre-trained model, do a transfer learning on top of it, and then finally what we are doing, like finally getting an output. We are able to train for a different model. Okay, so let's see. If you see the validation accuracies here, so it's like near to 0.9, like between, like it's not 100%, right? So it's somewhere around 0.9 to 0.92, 92%, right? So somewhere there. In case now, let's say you are not satisfied with this performance and you want to like improve it much better, then as we discussed in the last session, what we do is we will try unfreezing the previous layers. Okay, so in the pre-trained model you will start unfreezing the previous model. For doing that, what we should do is, for those layers we have to make the trainable as flag as like true. Okay, so what we do is previously, so let's do that. Okay, so it needs for this model to get completed. Till that time I can't do it. So by that time what I'll do is, let me walk you through the code from here. So I'll also keep these for run. Maybe you will able to see it here as well in later stage. Okay, so let's see what this code will do. So what they are trying to do is, this is a base model which initially they are making all as true, and then it means like all are trainable. So that is not required, right? Because you only want to free like unfreeze few layers, not the all the layers. So what you do is, in case if you have a kind of a model, let me do that. In case if you this is like input layer, one more input layer, one more input layer. Let's not input layer, it means like layers within the model. Okay, and this is your final output layer which we use. Let us say this is our model. Okay, ignore that global averaging and then, sorry, average pooling and then dropout layers. Okay, this is how your model is. Let us say that. Okay, so this is input and this is output. Okay, so taking this now, previously what we have done is, we have made all these as non-trainable, right? Till here to here, completely non-trainable, and only this as trainable, right? Previously this is how we have done. Okay, freeze trainable. So now what we do is, now let this is done once and we got like some accuracy of 92%, let us say. So but you are not satisfied with this accuracy and you want to go much further, then what you do is, you only freeze these two layers. Okay, and train these layers, make these as trainable. Okay, trainable. Okay, and these are like freezed, and here maybe you will get some better accuracy because you are also tuning these things, right? So apart from this, so maybe you'll get some 95%, let us say. So then what you do, still if you are not satisfied, you can unfreeze one more layer here. Okay, you only freeze this layer and train these layers. You can also do it like this. Okay, so maybe then you'll get like some better accuracy, 97%, right? So something like this, it may happen this way. Okay, let's see that like what it has happened. So here, by the time is it running? No, it's still training. So even though you can see if it is just a kind of uh, like what it is a transfer learning, but still like even though the parameters are low, you have this huge model which should compute on the data what you give, right? So it should compute the outputs, right? At least though you are not optimizing it, you have to compute the output. So it will take little more time, and also depends on your computational capability. Here each epoch is taking like almost near to a minute. Here they have shown us like it takes only 20 seconds nearly, right? So that again depends on your computational capability. So okay, let's go further here. So now I want to make like initially what I did is I made all as trainable, and then I will make few layers as non-trainable. So that is what is done here. So initially they made dot, if you put like entire model dot trainable, all your layers will become trainable. So and then what they are trying to do is like from first 100 layers you make it non-trainable, and then the later layers you want to make it trainable. That is what they have done here. So for the first 100 layers, base model dot layers from 0 to 100, what they did is the layer dot trainable is false. So what they did here is like they made layer dot trainable as a like false for first 100 layers, and the rest of the layers they made it trainable. So here actually there are if you take the length base model dot length of layers, there are 154 layers, out of which first 100 they are freezing, and the next 54 they are unfreezing it. So okay, let's also do the same way. Oh, this is not done yet, right? But once it is done, it will be quickly it will be done. So let me uh, type a kind of a test as fine tuning. Okay. Okay, so let me run it and let me add codes here. So now I'll start adding the codes what we have here. So initially we made the base model true, and to the base model, what we are doing is we are making this code. Okay, so first 100 layers we are making as a fault, and the rest layers will remain true. Okay, so let me run it. It will take time because like it's still running the above code. So by that time, let's move forward and see what we have. So for the same, actually, this base model has a connection to the model, right? So let's take this again. This time what we are doing is, because you are increasing the layers, so what we are trying to do is we are reducing the learning rate even by one more point. So previously it is 10 power minus 3, I guess. Now it becomes 10 power minus 4, or is it? Let me jump and check over there. So 1 2 3 4, so it is 10 power minus 4 earlier. Now we are even reducing even more to 10 power minus 5, because as your layers increasing, right? So it's better to start with like lower learning rate at the beginning. So okay, actually a higher learning rate mostly in case of images, right? So if you put like 0.1 0.01, usually it doesn't give like better values. So now let's see like what is a model summary after we made trainable, right? So previously there are only the 1281 like trainable earlier, right? So now the trainable parameters are like 1 lakh. So it's like 1 lakh 83. So sorry, it's like 18 lakh 63,873. So these many parameters now we should be able to train now. So even like previous one where it is like 1281, it is like taking a huge time, right? So it took for us like 10 minutes at least. So this will take hours. So don't expect me to run all this. Like maybe you can keep it for run and then leave it for a few hours to for it to train. So I'll also keep it and then show you the final output later. Okay, so this is the code here. So what we are doing is like to the previous one, because already the 10 epochs is already done, right? So to let it continue from there, just to That's why I think they have added this 10. Initially, they have run it from here, right? Where they only did not freeze anything. So they have freezed all and they only trained the previous layer for 10 epochs. From 11th epoch, what they are doing is they actually unfreezed few layers, like 54 layers, and they have freezed 100 layers, and they are giving this for training. So just for indication, so total number of epochs will be 20, and it already started, like where you can pass this history dot epoch, like where it is already 10, right? So it will start show it from there. So if you run it now, this is for fine tuning history. So you can see like it will start from there, like epoch 10, and it will continue. Okay, and you'll be getting again the validation. The other things are same, like nothing different, right? So finally, again, you can also plot the accuracies like previous. Okay, so let me add that as well, because we won't be able to run it, finish it so soon, I guess. So this may take again like 10 to 15 more minutes. Okay, so let me show you outputs from here only, like, because you'll be getting a similar kind of output. So what we can do is, so previously this 10th, like this, they have indicated this line here, which means that is a till here we did that one, like freezing of all layers except the last layer. Here we started leaving the last layer, right? So we started unfreezing 52 54 more layers from the pre-trained model. So what happened till here, it was near to 195%, but after you unfreeze again, it, because of fine tuning, it will more fine tune more, right? So your accuracy is even increased to something around like 98%. Okay, so that is cool, right? So even if you can see here, your training and testing loss till here, it is maintaining one slope. Suddenly it became sleeper and become like towards more towards zero. So it became faster here as well. Okay, so this is where this green line is where actually we started to do fine tuning till the other layers as well. So, and now after everything is done, we can evaluate your data on model.evaluate on test set to see how is it performing on test set. So on test set, it is giving like 97% accuracy. Yeah, that's it, right? So 97.9 accuracy. It is almost 98%. So this is actually done, right? Now we have trained it well. This will give you better performance. So jumping to the last part, like this is where it will conclude. So this is one thing like which we can use. So this is part of code which we can use it for like prediction. Okay, so what this will do is it is taken like just for viewing also. Okay, so this is a test set which will have image batch and like label batch. So this we take a prediction model dot predict on batch, and you pass the image like batch. So and you'll be getting a predictions over there. So on top of it, actually what you'll be getting is like values for like zeros and ones. Okay, like how much is it for a cat and how much is it for a dog. On top of it, what we are doing is a sigmoid. So actually what you get is a values here, right? So if you use a sigmoid, you'll be getting a probability. So this probability, if it is less than zero, you can treat it as a cat, and if it is greater than zero, sorry, not zero, it is greater than zero point 0.5, you can treat it as a dog, something like that. Zero means like cat and one means dog, and then according to it, you take like images, you plot it here and then show. So that is what is done here. So where this is like they also printing the predictions, and actual predictions are like this and actuals are like this. So where zero is cat and one is dog. Okay, so finally you are able to predict like this. So in this case, you are able to predict cat as cat, dog as dog, here cat. So all cases it has done pretty well here, right? So for all these bunch of images, it has trained properly and it was able to predict well. So this is how we can use transfer learning for doing a classification task. Okay, so yeah, this is a kind of a lengthy one. Yeah, and there is like one more thing similar to this transfer learning. like there is this transfer TensorFlow hub, which like I'm not going to run any of these. Like just I'll walk you through the model. So what you'll have is it will even simplify your usage of your code. Okay, so hub dot Keras layer, then you can use the classification model which you want to use. Like mobile net previous is like this, right? Previously we used a different technique to load it. So here you can give the URL. It will, if you do like Keras hub dot Keras layer and then give the model URL here, it will automatically download, and this will be your model here. Okay, to this model you can start adding like some like model dot add, and then you can add like few things and then finally get a prediction. So here I think they did not do any fine tuning, maybe they did it towards the end. So but the process is same, right? So this was a completely different data set which they are trying. Like it has so many different things here. Okay, so this is one more thing which you can try. So here you can see, so feature extraction layer, and to it they are adding this dense layer. Feature extraction layer is some part of one layer before of your mobile net, and then that they have taken, and finally they are doing the same thing. Okay, so you'll be getting this way. So in next classes we'll also see the early stopping mechanism, how they have used. Maybe if it is there here I can show it, or else like let's implement it by ourselves. Okay, so I think that's it for today's session. We'll see the rest of the things like in next session. Okay, finally you can do model.save and then give a path where your model will get saved. So the trained model what you have, right? So if you want to save that model, you have to do model.save. And similarly, if you want to load your trained model later, you can do this way. So keras.model.load model, and it will get reloaded. Okay, so this is how you can do it, because like you train a model now today and you want to reuse tomorrow, again you don't train it again, right? So what you do is you save the model and then use it back. So for that purpose, dot save, and then finally while loading keras.models.load model. Okay, so this is how like these are saved and used. So usually they use a format of h5. So let's follow the same and then use it. Okay, so this is about implementation of transfer learning for and doing a task. So you can see here that like the training is done even for fine tuning task. So it has taken around like 15 minutes, I guess, like for training these next 10 epochs. So now, like while we try to plot it, we have plotted it, and just like as we explained before, so it has performed the same way. Like the accuracies are towards like 0.98. Okay, so it's like 98% nearly. So similarly, both laws were down. So you can experiment, as I told before, like because you are doing like regularization techniques, right? So there is no overfitting, like it is doing pretty well. So in case if you want to know like the difference, you can remove the dropout layer, and also remove the augmentation, data augmentation technique, and then also maybe the global averaging as well, right? So you can remove those and then see, like maybe in that case you might not get this much cleaner graphs. Okay, so like because like it won't be regularized. So apart from that, we can test. This model is now trained, right? So if you do dot evaluate and test set, finally we have got like 96.8 accuracy on the test set, so which is also pretty decent. So this is about it, like using transfer learning for doing a classification task, right? So where we have classified between dogs and cats. So let's also see here, like there is a code like given, where like it has taken this data, like on the test data they are previewing like first 9 data points with the predictions. So they're making the sigmoid like where, right? So let's see the same thing. Let's run it here and see if we are getting the same thing here. Okay, so this is how it is, and then yes, finally we got the dogs, cats. Like actually, yes, pretty decently it has classified between dogs and cats. So this is how it is done. Yeah, that's it about like transfer learning. Let's